Greetings everyone! Today we will present to you our project for production and operations management. This video will be a discussion and explanation of project evaluation and review technique using critical path method. A presentation made by Group 5 of BIT for FSMA. Project evaluation and review technique is a project management technique that plans, schedules, and controls uncertain activities. Using a statistical technique like critical path method allows an organization to evaluate duration time and identify tasks that are necessary for project completion. Here are the agendas that we will execute for further discussion. Construct a project network. Perform forward and backward passes, determine project completion, calculate slack values, and state the critical path. Here is the formula we will be using to get the critical path. A stands for activity, T stands for time, ES means earliest start, LS stands for latest start, EF means earliest finish, and LF for latest finish. This formula will be our guide all throughout the discussion to get the critical path. This critical path formula has two parts. We will be performing forward and backward passes, which was already mentioned a while ago. Forward pass is a process to determine the early start or early finish time of the activity, while backward pass is to determine the late start or late finish time of the activity. Remember, with forward pass, you move from left to right of the diagram to add the duration time to the early start value. For better illustration, you add time and early start to get the early finish. But with backward pass, you move from right to left, subtracting the time from the late finish date. For better illustration, you subtract time to the late finish date to get the latest start time. Please take note of these passes as we go along with the given computation. Here is SMR Innovations Company Limited. This company has tasks from A to I that needs to be accomplished. Predecessor refers to the task that must be completed before another task can begin, while duration time is the estimated time for the task completion. Using the critical path diagram, we will identify the completion time of these tasks. Basically, it will start first with activity A, followed by activity B, which relates to the prior task. Activity C is also depending on A, so we will have to connect C on letter A, while letter D and E are both depending on activity B. As task F depends on C, and letter G depends on both E and D. Task H is connected on activity E and F. Then lastly, letter I depends on activity H and G. Once the last activity is identified, it will be the finish date of the task completion. After identifying the task dependencies of each activities using this network diagram, let us now create and follow the critical path formula for better illustration. We may now add the duration time below the activities of each diagram following what is on the given. To compute the activities, we will perform a forward pass, adding the earliest start and time to get the earliest finish. Starting off with letter A, we can put 0 on the earliest start since it has no predecessor. When we add 5 plus 0, it will be 5 and that will be the earliest finish for activity A. For letter B, the earliest start will be 5 coming from the earliest finish of activity A. Adding 10 plus 5 is 15 and this will be the earliest finish for activity B. For letter C, we will also have 5 from the earliest finish of task A. So 13 plus 5 is equals to 18, which will be its earliest finish time. Activity D will have 15 as the earliest start. Adding 7 plus 15 is 22 and this will be the earliest finish date for this activity. Letter E depending on B will also have 15 as the earliest start. So 3 plus 15 is equals to 18 to be the earliest finish. Activity F is connected to letter C. We will have 18 as the earliest start, which means we will add 9 and 18, and the answer will be 27 as the earliest finish. For letter G that depends on both D and E, we will have to assess first which activity from them has the highest early finish to get the earliest start for task G. Since 22 is greater than 18, we will be using 22 as the earliest start. So 4 plus 22 will be 26, simply means that 26 is the earliest finish for task G. Same process for activity H that is depending on task E and F. Since 27 is greater than 18, we will be using 27 as the earliest start. So 3 plus 27 is equals to 30, which will be our earliest finish. The last diagram will be task I that relates on activity G and H. Given that 30 is greater than 26, it will be used as the earliest start time. So 7 plus 30 is equals to 37, means that 37 days is the completion time of these tasks. Now that we got the estimated task completion time, we will now perform a backward pass to compute the latest finish and latest start. So it will be the latest finish minus time to get the latest start. Since 37 days is the maximum latest finish, it will also be used as the latest finish on diagram I. So to get the latest start on this activity, it will be 37 minus 7 equals to 30 as the latest start. This latest start value from task I will be used as the latest finish of activity G and H. So we will subtract the time of each activity to 30 so we can get the latest start time. Once identified, we will copy 27 from diagram H to be the latest finish value of activity F. Now when we have 27 minus 9, 18 will be our latest start. For letter E, we have to identify which from task G and H has the least latest start to get the latest finish of task E. Since 26 is less than 27, we will have 26 to be the latest finish on this diagram. So 26 minus 3 is equals to 23. For letter D, we'll just have to copy 26 on diagram G to be its latest finish value. So 26 minus 7 will be 19. Diagram C will get 18 from activity F, so 18 minus 13 is equals to 5 as the latest start value. Meanwhile, on activity B, we will find also which from task D and E has the least latest start value. Since 19 is less than 23, we will have 19 as the latest finish value, and that will be 19 minus 10 to get 9 as the latest start. On the last diagram, since 5 is less than 9, we will use this to subtract the 5, which is the duration time. So 5 minus 5, the answer will be 0. Now that we have determined project completion, we can now proceed on computing the slack values. Slack is a term that describes how long you can delay a task before it affects the activity sequence. To compute slack values, we either subtract LS and ES or LF and EF. Going back to the network diagram, the slack on activity A is 0, for B is 4, C also has 0, D has 4, E has 8, F has 0, G also has 4, then both H and I has 0 slack. Once slack values are computed, we can now state the critical path by looking which activity has 0 slack. Therefore, the critical path will be A, C, F, H, and I. This critical path is the longest sequence of activities that must be finished on time for the entire project to be completed. Finally, to sum up everything that we have discussed, critical path method is a useful project management tool to help you prioritize tasks and deliver project on time. This would be all from our group, and we hope that you understand the lesson very well. Thank you for listening and have a great day.